Hello everyone, welcome to Benji Physics. This is me, Bandar Dolbet. In the previous video, we talked about angular displacement and how to calculate it. However, in our today's video, we are going to talk about angular speed and velocity and how to calculate it. Well, our question in this video today is what is angular speed and what does it measure? But before we dive into details about angular speed and velocity, let us first introduce linear speed as we need it later on. Well, linear speed is just the speed of an object that moves in a linear path. For example, the speed of this orange dot as it moves along this linear path, we call it linear speed, and it's measured in meter per second. So now from this simple example, I believe that you have correctly guessed the meaning of angular speed. Well, angular speed simply is just the rate of change in angular displacement over time, or it's just the speed of a rotating object. For example, the speed of this red dot while it is rotating this circle called angular speed. And as you see, the angular displacement change over the time. Regarding the measurement unit of angular speed and velocity, well, both are measured in radian per second, because the angular displacement divided by the time. And one notice I should highlight here is that angular velocity and angular speed both are denoted by the Greek letter omega. Well, you might be wondering what is the difference between angular speed and angular velocity? Well, the angular speed and angular velocity in fact are similar and both have the same measurement unit, which is radian per second, and also the same formula. But the difference is that the angular speed is just a scalar, which is mean we do not consider the direction of that speed, we only consider the magnitude of the speed. But on the other hand, angular velocity is a vector, which is mean we consider both the direction and the magnitude of the velocity. For example, here the orange arrow here shows that the velocity of the white dot is changing constantly due to the change of direction of the speed each second. Also, pay attention that angular velocity written as omega and above it an arrow to show that it is a vector. Our most important question here is that how to calculate angular velocity. Well, before we jump into the formulas, let us establish a foundation for this part. A complete cycle of this dot gives us an angular displacement equal to 2 pi. For example, this dot, if it's rotated around the whole circle, then the angular displacement is equal to 2 pi. And you can check my angular displacement video to know more about it, the link in the description below. However, taking the angular displacement for a complete cycle as 2 pi, then the angular speed can be calculated using the following formula. Angular speed as a scalar or a vector 2 is equal delta theta over delta t, or 2 pi over capital T, or 2 pi multiplied by f, where delta theta is the angular displacement measured in radians, delta t is time in seconds, capital T is the time periods, which is the time the object takes to rotate a complete cycle. F is the frequency measured in hertz, or a complete cycle around a circle. And to calculate angular velocity as a vector or scalar 2, we also use the same formula, or we can use the linear speed to find omega. As stated here, angular velocity equal delta theta over delta t, or v as a linear speed over r as the radius of the circle. And actually this equation we use it to calculate the linear velocity. If this seems a bit complicated, do not worry. Let us take two examples using the two equations here to make this more clear. And let us start with the first equation here. In example 1, let us find the angular velocity of this centrifuge as it makes 6.4 revolutions in 4 seconds. And to find the angular speed of the centrifuge, in fact, there is two ways. First, we can multiply the number of cycles, which is 4.6 by 2 pi, and divide it by time period, which is 4 seconds. And it's equal to 10.05 radian per second. And the second approach is by using the frequency, which is obtained by dividing the number of cycles 6.4 by the time period 4 seconds. And this gives us 1.6 hertz. And then we multiply 2 pi with the frequency to get the omega. and it's equal to 10.05 radian per second. Moving to the second example, we are going to find the linear velocity, the velocity that me and you familiar with since grade 9, which is measured in meter per second. Well, the example here is to find the linear velocity or the speed of a point that rotates with angular velocity of 18 pi radian per second at a distance of 12 centimeter from the radius of the circle. And if you recall the second equation for this example, the equation that states omega equal v as the linear speed over r as the radius of the circle, then you are correct. Here simply we put linear velocity v as the subject of the formula and multiply omega by the radius, and this equal to 216 pi centimeter per second. Now we have come to an end for this part. In the next video, we are going to talk about centripetal force and how to calculate it. One last thing, your likes and support will encourage me to do more content like this. So if you like my explanation, please hit like and subscribe to my YouTube channel so that you get to see the next upcoming videos. Thank you.